this at least. Okay, so we've got y equals sine x. Y equals sine x looks like this. We've got y equals cos x. 1 cos x looks like this. Is it lagging? Oh, good. So sine x looks like that, cos x looks like that. Tan x not too much. Tan x looks like this and has an asymptote at 90 degrees, and tan has a period of only pi, and tan pi on n. Tan does not have any amplitude. So we're all happy with that? We've kind of memorized that, or can memorize that. We need to know the reciprocal functions as well. Reciprocal functions will follow extension 1 strategies. So do you remember what we did with extension 1? Reciprocal functions? Did we do that? We haven't done reciprocal functions. No, we did. We did do reciprocal functions. Asymptotes become, intercepts become asymptotes. Happy becomes sad, sad becomes happy. So extension 1, to you guys, it should be really easy. Advanced, you've got to learn that particular technique. So let's draw the other ones. I'm going to superimpose them on top of them, because I'm guessing we know these black ones. So I'm going to do the other ones on top, so you understand what is exactly happening. So with green, 1 over sine x. What's 1 over sine? That's the same as saying cosec. Okay, how do we draw cosec x? Intercepts, intercepts become asymptotes. Intercepts become asymptotes. There it is. Looks good. Why does it become asymptotes for those who are in advanced? What's 1 over 0? Undefined. 1 over 0, undefined. 1 over 0, undefined. So all those three, undefined. Then, what's 1 over a small number? 1 over very small gives you very big. 1 over a little bit bigger gives you a little bit smaller. 1 over a little bit bigger gives you a little bit smaller. A little bit bigger, a little bit smaller. What's 1 over 1? Still 1. And then, obviously, it's symmetric. So what we tend to memorize is, if it's sad, it becomes happy, but there it is. You're approaching your two asymptotes and it looks parabolic in nature. And same thing down here. So please don't memorize cosec, sec, and cot. I think it's better to understand how they work, because then you're going to memorize 6 graphs. Why would you want to do that? You've got all stations are central, sine square. You've got lots to memorize already. Okay, feels more comfortable second time around? Good. Let's do the same thing again for cos x. What's the reciprocal of cos x? 1 over cos, sorry, oops. Let's draw that in green. Y equals 1 over cos, which is the same as sec. Let's draw sec x now. Same things, where do we start from? Intercepts become? It's happy at the bottom, so it should become sad. Again, what's 1 over small? Big. So this one's actually going to come from here now. And 1 over a little bit bigger will be a little bit smaller. 1 over a little bit bigger will be a little bit smaller until it gets to 1. So this one looks like this. The reason why, because the other part of it, just so you guys understand this, see, if I continue my cos curve, we all know it looks like that, right? So can you see that you would have had an asymptote here, and then this would have been the other half of your parabola? So it's just cut, your parabola's just been cut in half, because obviously it starts already in midair. Just so you know. So I'll leave it in there, maybe dotted, so you guys know that it is technically still a parabola. It's just Obviously for the one cos we've got, it just starts off like that. And then same thing down here. Again, 1 over small is going to be large, so we're going to start up here and we're going to come down. And that's your cos curve. That's it. Again, of course, you guys know it can continue. So if you had continued, it would look like this, asymptote, then you draw another one down here. Asymptote, you would draw another one up there. Whatever. Looks very similar to its friend here, cosec. All right, yeah, cosec. All right, rub. Happy with that? And last one, cot. Y equals 1 over 10, which equals cot x. All right, 1 over 0, undefined. 1 over 0, undefined. There you go, so you guys don't confuse yourselves. 1 over undefined. What do we say? Very weird. 1 over undefined. Well, technically it should still be undefined, right? But let's have a look at something. 1 over 0. 1 over 0 is undefined. 1 over an undefined, well, 1 over a fraction actually is the reciprocal of the fraction. So that becomes 0. 1 over undefined somehow becomes defined. So 1 over something that doesn't work actually works. Nice. I just showed you the math. Technically doesn't work though, but I'll explain that in a second, so hold on. So that will work, so that means it'll cut through. So let's go through it again. 1 over 0, 1 over a small number, what are you going to say? Big. 1 over a little bit bigger, a little bit smaller. 1 over really big, really small. So now when it's going to start up here, it's going to come down. 1 over really small, really big, really small. 1 over really small, really big. It's actually a cubic, or what you guys see as a cubic. So it look like that. Now it's really important. A lot of books I don't think have the open circle in there, but there is meant to be an open circle because technically if tan 90 never worked, 1 over tan 90 should still not work. It will cut through, but you got to see asymptotes as windows. That's what you'll learn as you continue your year 11 and 12 career. They're windows. They're not walls. Walls you can't go through. Windows, they can open and close sometimes, as you want them to be. So yes, we're going through it, but yes, it's going to be an open circle. So it doesn't really exist, but it's going through it. So weird, but that's how that works. And that's it. So it's like a cubic. But yeah, 1 over an undefined technically becomes defined, so it can go through now. That's what you want to understand from that. Okay. So the question said draw sine and cot. You would have drawn this one in black. You would have drawn this one in black, and then you would have drawn this one in green on top of each other. And that's it, really. But it has to be almost memorized for you to be able to draw it out. Okay. Stop that recording.